So what we're going to talk about here is a way to write sums of a lot of numbers in a compact way. Just going to work a couple examples. It's going to look a little intimidating maybe at first because we've got this Greek letter sigma showing up on our math problem. But after one or two examples, I think you'll be comfortable with what we're doing here. So this is what the form of the problem is going to look like. There's always going to be some number, at the bottom, and then some number at the top. There's always going to be a variable. I and j and k are typically used most often. The I here and the I here in that expression are aligned. What we're going to do here is we're going to start by plugging in I equals 1 to that expression, 3i plus 2. So I get 3 times 1 plus 2. And then we're going to plug in I equals 2. And so I get 3 times 2 plus 2. And then I equals 3. 3 times 3 plus 2. And so on until we get to the number on the top. And so I equals 4. And then I equals 5. And then if I wanted to simplify that further, I could do that. 3 plus 2 is 5, 6 plus 2 is 8, 9 plus 2 is 11, 14, 17, and then, whatever that adds up to be. And so 13, 24, 38, 55. I think that's right. So this expression that I started off with is equal to 55. Try another example. Say I do something like sigma, we'll put I equals 4 on the bottom and then 10 on the top. And we'll just put like 2i right here. So now I've got I equals 4 will be the first value that I plug in. And then I'll keep plugging in I values until I get to 10. So it'll look like this. 2 times 4 plus 2 times 5 plus 2 times 6 plus 2 times 7 plus 2 times 8 plus 2 times 9 and then plus 2 times 10. And then I stop because 10 is the number on the top. So that number on the top is always telling you the last I value to plug in, not how many values are going to be in the sum. If I were to go and look at this, there's 1, 2, 3, 4, 5, 6, 7 terms in this sum, starting with I equals 4 here, going up to I equals 10 here. Look at one more example where we're expanding a sigma. Let's say I equals 1 to 6, negative 1/2 to the I power. And so I start and I get negative 1/2 to the first, plus negative 1/2 to the second, plus negative 1/2 to the third, and so on. And so starting with I equals 1 because that's the number here, finishing with I equals 6 because that's the number here. And so that's an expansion of that sigma notation. The other version of the problem would be to go the other direction. So for example, I might say, rewrite the sum using sigma notation. So maybe something like this: 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 18 squared. And so you have to sort of recognize what the pattern is, that in each instance that looks like that could be I equals 1 and then I equals 2 and then I equals 3. And so this would be I equals 18. So my sigma is going to start with an I equals 1 at the bottom and go to 18 on the top. And then what's the formula for the sequence? 1 over I to the second power. Same idea, maybe a little bit harder. Let's say I go 1 plus 8 plus 27 plus 64 plus ... all the way up to 729. It's a little bit of problem solving that you have to do in this instance, in that I'm recognizing that 1 is 1, 8 is 2 to the third, 27 is 3 to the third, 64 is 4 to the third, and so it looks like these are a bunch of cubes because 1 to the third is 1. You may recognize what number cubed is 729, and if you don't, you can use your calculator and figure out what the cube root of 729 is to see that that last term there is 9 to the third. And so here I'd end up with the sigma notation I equals 1 to 9 of I to the third power.